Uh, Hello, very good morning, all participants. Welcome to the first session of day 4 of the training program. In the first session, I will be talking about environmental and social consideration in the master planning. As I mentioned, the recent guidelines, whether it is NWP 2012, IWRM 2016 or CWC guidelines, the emphasis has been given to consider the environmental aspects as well as the social aspects for planning the river basin or preparing the river basin master plans. So, as you are aware, what is the basin? Basin, it not only the water, the characteristics, rainfall, it also considers the nature as well within the basin and the livelihood, the people, communities who are living within the basin system. So river basin, holistic, the river basin, we consider three components. One is water, which is surface groundwater, availability of the water resources, as well as the social culture, livelihood within the basin, and the nature, biodiversity, environment, flora and fauna. So these are the major component we should consider within the river basin system if we talk about the river basin master plan. Without these the social and environment consideration, your master plan is not complete as far as the recent guidelines are concerned. Before starting the master plan or planning for the master plan, to consider these two aspects, environment and the socio-economic aspects, we should have a database, and then how to plan the database. Then yesterday one of my colleagues was presenting regarding the Dikrong case study where he was like soil strata and all these he was mentioning. So these things are prime factor deciding the soil topography, slopes, the various regions, hydrometeorological characteristics. So we should have all those information available, which part of the basin is mountain region, which is the valley, plain, where is the agriculture fields, what are the water diversion schemes, what are the pockets where the livelihood aspects are there, what are the communities, which are the communities which are living nearby the basin area. So these aspects, then soil geological characteristic, what are the soil strata, aquifer system. So we should consider all those things while preparing the database for the environmental consideration. Then important part is obvious, this is the main component of the master plan, the river system, which is climate and rainfall. The rainfall, temperature, surface water flow, groundwater flow, sediment, erosion, all those things should come also in picture in while preparing the database for the basin. Then drainage system, what kind of drainage network, the first order stream, second order stream, third order stream, and shape of the catchment. Yesterday I have mentioned in my presentation that to estimate the peak flow of the basin at the outlet, the shape of the basin plays a vital role, because your shape will decide if same intensity, same amount of rainfall is occurring in your basin, then your shape of the basin will decide what would be the peak at the outfall of the basin. Then land use, land cover, what kind of land use regulations, planning, whether it is forest area, urbanized, the irrigation area, then what are the water bodies, lakes, these are also should come in the picture. Then important component is the forest cover. How much of area of the basin is protected area, the forest area, whether forest is declining or increasing, what are the causes of the deforestation, afforestation schemes are, is there any in the basin. So we should have the information, all those schemes available within the river basin system. So next one is the water quality. So the water quality links to both environment as well as the social aspect. If better the water quality, the better the social aspects or livelihood will be there. And environment, though the qualities, degradation of water quality, all these information will play the big role in this deciding the environmental and the social factor in the basin. So water is usage, I mean the drinking, bathing, irrigation, ecological needs, environmental flow, irrigation, all these major components where water is being used within the basin system. So these are, I mean there are some guidelines, I mean BIS code are there, like BIS code 22961992, it tells about the water quality parameters. There are standard guidelines. So different water quality parameters, there are some acceptable limits range and permissible limits. So what, I mean your water is, quality of water is ranging in which criteria? So these guidelines are telling that okay, your water quality should be this before, if you want to use this water for irrigation, for industrial use, for agriculture, for drinking. So these are some guidelines, like for dissolved oxygen should be greater than 5 mg per liter, and biological this oxygen demand should also be some, there are some ranges where this BIS code suggests the limits are there. So in master plan, like yesterday we have shown you one example for Dikrong river basin, where there are different locations were there, and at the few locations the quality of water like arsenic content, iron content, pH, turbidity were increasing trend, and somewhere it was decreasing trend, and through pre-monsoon, then monsoon, post-monsoon, different kind of changes were there. So we should have information, all those things, water quality parameter. This is the important aspect we should consider the master plan. So these are few parameters. There are number of parameters to assess the water quality, but there are few main, like pH, dissolved oxygen, then BOD, COD, turbidity, TDS, nitrate, phosphates, and iron content, arsenic content. These are few important parameters. Then there are different sources, I mean which are responsible for these water quality aspects. One is point source pollutant, where your industry is there, like in Itanagar, I was giving the example yesterday. There are few locations where industrial waste is meeting to the river, in the Dikrong river. So these are the point source, I mean it generates the contamination in the river system. And then there are non-point source also, like in the agriculture field we are providing the fertilizer, pesticides. So there are not the uniformly, I mean there are not the point location we are putting those I mean sources, but these are uniformly distributed over the agriculture fields and all. So these are non-uniform source of water pollution or contamination. Same thing, I mean time frame, before moving forward we should have the time frame, the what should be the duration for which we should collect the water quality parameter. At least 2 years consecutive observation should be there to identify the trend of the water quality parameter. So there are different agencies who are monitoring the water quality parameters for a river system. There are central agency as well as the state agencies, local agencies also monitoring this quality parameter. Like in the northeast, I have seen at many places where the CWC sites are there, I mean the CWC gauging site there, they are also monitoring the water quality parameter there. The WRD is also the army, I mean the division within the WRD, they are maintaining the records of water quality for the Assam. Likewise, the other state departments are also maintaining the records of water quality. Central agencies, Central Pollution Control Board, Central Water Commission, then State Public Health Department, they are also monitoring and maintaining the water quality parameters. So, as I mentioned, the BIS code recommends some limitation or permissible limits you should have in your water, in your basin. So, you should consider all those aspects while considering the water quality parameters and water quality status in your river basin master plan. On India scale, as I mentioned, the Central Pollution Control Board is the responsible agency for the water quality monitoring and measuring as far as the river system is concerned. So they have categorized the river system based on different rank. I mean, first order, second order, third order, all these priority 1, 2, 3, 4, 5. So in the map you can see which basins. It's not necessarily the settlements, industries are also contaminating the water. The agriculture field, agriculture activities, which are also, I mean, the non-point source water quality aspects, these are also play a major role while polluting this river water quality. So in the river system, you can see Godavari, Kaveri in the southern part of the India. Of course, Yamuna is there. Yamuna, the water quality is deteriorating. If you see an image in the news channels, you might have seen how the water quality has been deteriorating over the years. Then Satluj, Ghaggar also the rivers, and Assam, the Brahmaputra is also one of them. So in the Brahmaputra river, though this falls under moderate category, the water quality rank is considered, but still there are few pockets where some, I mean, problems are there, like arsenic contamination is there, then iron contamination is there. Then in other states, there are few locations where water quality problems are there in the different river basins. So Assam, this map shows the water quality aspects like arsenic distribution of the Assam state. See this Golaghat region, Jorhat and Golaghat region is highly, I mean, the arsenic contamination is crossed 50 parts per billion ppb. So similarly, there are other informations available with the competent authority which are maintaining the water quality records. So we should collect at least the major components like pH, TDS, hardness, nitrate, fluoride, arsenic, iron content, and we should consider those aspects in the master plan, and we should present what is the current status of the water quality aspects, because these water quality aspects are linked to both the social as well as the environmental aspect of the basin. This is example of the Krong. Yesterday also we have seen this. Some places the water quality pre-monsoon, there are quality issues. Then once the, I mean, flood season is over, then after the post-monsoon, the water quality improves a lot. For example, this is iron content in one of the location in the Krong River Basin. Note the different locations in the Krong River Basin. Then there are two lines. One is pre-monsoon and post-monsoon water, this iron content. So you can see in the post-monsoon, this contamination has been drastically reduced, almost all these locations. Now coming to the aquatic ecology and fisheries, biodiversity. So though we have mentioned northeast states are rich in biodiversity, the terrestrial, I mean the ecosystem, aquatic ecosystem, it's rich in biodiversity. A lot of wetlands are there, beels are there. The Dipor Bill, which is, I mean, near this airport in Guwahati, also considered one of the Ramsar sites in the northeast states. So these Ramsar sites and then beels, wetlands are helping in maintaining the river ecosystem, the fish biodiversity. Then some examples like Kaziranga Park, National Park. So you can see in my first lecture I have mentioned the pulse hydrology. Pulse hydrology is nothing but the low magnitude flood near the river which I mean low magnitude flood with the nearby area maintain the ecology or biodiversity of the region. One example I showed you of the Kaziranga National Park. Without this pulse hydrology or this low magnitude flood, we cannot maintain this biodiversity or ecology in the system. So the flood is required there to maintain the fertility of the soil, to maintain the ecology, to maintain some species, I mean, which are good to strengthen or maintain the river ecosystem. Flood is always not the, I mean, low magnitude flood is good sometime to maintain those river ecosystem. So we should consider all those aspects. Then why these river ecosystem, fisheries, biodiversity is it's on threat because of some measure, I mean, the flow alteration like dams. We are preparing the dams, but we are not maintaining. Though there are guidelines, we cannot build a dam without consideration of those aspects. There are some guidelines, stages are there, the approval stages are there, but somehow they are, I mean, disturbing our ecosystem, river ecosystems. Because there are two things: one is development, another one is the, I mean, the social and environmental aspect. So we should, I mean, take a approach to balance all those things. I mean, while the developing, I mean, preparing this dam, hydropower projects, we should also think that our river ecosystem, biodiversity, environmental flow, all these aspects should be considered as per laws, government laws. So fish production here in Assam as well as the northeast states, it's a good, I mean, they are maintaining ecosystem as well as the good source of income in the livelihood. There are communities which are, and based on those these fish production, they are for their, the fish production is their, I mean, daily wage, like they are earning from the fish production and the livelihood aspects which is linked in the northeast states with this fish production and the aquatic vegetation, aquatic ecosystem. So aquatic ecology, fisheries, these are some species which are, I mean, available within the river system. Few of them are not available in the northeast states, but many of them are available, which are responsible to maintain this river ecosystem, like flora, fauna. Flora is plants, all these, I mean, that grow in the partially as fully submerged water area. Then animals, which are also, I mean, required, they should not disturb while we are planning something in the master plan. So we should consider all those aspects in master plans. Few examples, because we have received some data from the departments, state government agencies, how the fish production are, I mean, their seed production as well as the production in tons. So how they are changing over the years. So we have seen that in Meghalaya, though this is varying region by region, district by district, but overall as a whole for the entire state, these are increasing in numbers. So this is good part of that, because we are maintaining a healthy ecosystem as far as the fish production is concerned. Then forest is also important component of the master plan. There are some major threats with deforestation, specifically in the Assam and also the other states also. Deforestation, the forest area is decreasing. Like yesterday we have seen for Arunachal, the Papampare district, the forest area is declining over the years. Okay. So in the land use sense, there, if something is in the declining mode, then I mean, some other component or other aspects which are increasing. For example, urbanization, agriculture field activities. So these are increasing and forest area is decreasing, because we are using the forest land for that purpose only. So final, I mean, the conclusion in the master plan, it will come as a recommendation, but these are the few preliminary analyses that trends are showing based on the available data in the river basin from the respective departments. So see, this is tree cover area loss in Meghalaya. Meghalaya, the example is the from 2001 to 2017. The tree cover area was increasing. Then from 2017, I mean 18 onwards, it is again in declining mode. Okay, so there are some reason behind it, why this tree cover area or the forest area is decreasing or declining mode. So we should know the root cause, what is happening if the forest tree cover area is declining, then there are some root causes there. So we should analyze this and we should present in our master plan. Wildlife in India, I mean, you are aware there are more than 100 national parks. The Northeast rich in biodiversity. We are already aware of it. Then in Northeast states, there are more than 15 plus national parks, 60 plus wildlife sanctuaries across all states. So we should, we should produce these information. So you all might have visited in this place. This is a good place for tourist point of view as well as for ecology or biodiversity and environmental point of view. You should visit this place. You might have already visited. We have also visited once. So see, Brahmaputra is maintaining this ecosystem, the Kaziranga. And their low magnitude flood, as I mentioned, this is maintaining the ecosystem there. So rhinos are there, so which are, everybody knows, good place, tourist as well as the ecosystem maintenance in the northeast state, especially in the Assam. There are some other examples, Manas National Park, and Namdafa National Parks, then some other national parks are there in northeast. And in the Assam, not only in the Assam, for all northeast states, the wetlands are, good in terms of number, in terms of storage of the water. And as I mentioned yesterday, they are also playing a good role to reducing the floods. They are reducing, the flood. Wherever there is peak flood, the nearby oxbow lakes or wetlands, they are accommodating this flood, peak magnitude of flood for some time. So they are also maintaining the river ecosystem and they are also reducing the flood. So they are also, producing some species. So this is good part that we are maintaining those. Then we should plan in our master plan how to maintain these river ecosystem, wetlands, there are beels, all. I have seen and I have gone through some literature, like as I mentioned, the this Dipor bill, Guwahati, is being encroached by the nearby residents, or the catchment area or the water body area is reducing, shrinking year by year there. So this is not good. We should have some plan to maintain this ecosystem. So in master plan, because Dipor bill is the one example for larger water body, there are small water bodies are there, wetlands are there within your river system. So we should maintain those. We should provide provision to maintain. We should have some facility to have this. Their restoration plan or their strengthening plan should also be there in the master plan. We should consider these aspects in the master plan. So in Assam, approximately this 37.2% of the state's area covered in the forest, we know, but wetland area is 8,672 square kilometers. These figures are coming from these sources, but we should estimate the trend, because how your wetland area is increasing, decreasing, and that remote sensing application like NRSE, ISRO, NRSE is also estimating those. Then Space Application Center, not the central agencies, but the state application center, like for Assam State Space Application Center is maintaining all those records. So we have received some data on this, but while preparing the master plan, we should get this information, how the wetlands are changing in terms of their areas and their capacity of the water storage capacity. So we should estimate those. This is the statistics of Assam state, how the wetlands, percentage, number of wetlands, natural as well as man-made. There are some man-made wetlands also there. They have been prepared for some objectives, like to maintain the river ecosystem. So in Assam, the number is good, and river and streams are playing major share. More than 80% part is, because Brahmaputra is the river, is width is more than 10-11 kilometers in throughout the stretch. So mostly more than 80% part is covered by the river and streams. If you talk about these wetlands, water bodies in the state of Assam. This is the power wheel we have discussed. These are the species. We have received this data from Fisheries Department, and we have presented here this. Then environmental flow. Environmental flow is the first aspect we should consider while preparing any water diversion, water storage, any structure on the river system, any plan. Then we should consider the environmental flow. There are some guidelines what should be the minimum flow for the basin. So there are some national guidelines, the regional guidelines also there. There are some international agencies which are providing, some portals are there for the region specific, what should be the environmental flow for your region. Though there are rough estimation, but you can estimate what should be the environmental flow in my location. So for example, this IWMI, International Water Management Institute, they have a platform to calculate the environmental flow for your region. The northeast region, what should be the range in terms of percentage? Though somewhere there are coming around more than 80% flow, but you should at least consider this aspect, because there are some national guidelines as well to maintain like 20%, 25%, and the region specific guidelines are also there. But we should also consider what the international agencies are saying who are maintaining this environmental flow. So their portal is there, you can explore. I mean, they have given the requirement for all the places. Then EIA, you are aware of this environmental impact assessment. This is the procedure you should follow. There are some guidelines. You should take the approval from the Ministry of Environment and Forest, and after the clearance, you should, proceed for this setup of any project in your basin. So as integrated component, these are the some component. The water quality is the main, which links to the social as well as the environmental aspect. In Guwahati, I can tell you, I have visited number of places within the city, Guwahati. There is a river, the Bajiya river. Those who are living in the city area, you know, this passing through the main city center, the Paltan Bazaar area, and you might have seen the condition of this Bajiya river. Nala, you search, you see, you ask your friends, what is the condition? This is creating problem for nearby communities, waterborne disease, the environmental issues, the air pollution, the water quality problems, the groundwater problems. And where this Nala and the river meets to the Brahmaputra river basin, on every year there is a problem of flooding there, because this Bajiya river, the capacity has been reduced because people are dumping the waste in the river system in this region. So capacity has been reduced. So during the monsoon season, wherever there is a high amount of rainfall in the upstream catchment within the city, it's overflowing because the capacity is not there. So the nearby area, 1 meter, 2 meter, 3 meter water depth, all these areas are getting inundated almost on every year. So, and one more thing, the GMDA, Guwahati Municipal Corporation Limited, they are also, because this river system Nalas falls under their jurisdiction. So one more thing, the area near the Brahmaputra, this Nala is meeting, the river is meeting, this is the low-lying area. So wherever there is a high flow in the Brahmaputra river, then this is also creating a backflow in this river system, and which are also creating the flooding problem. But my point to mention here that the quality at the, quality of water in this river, especially during the lean season, it's very bad. So there are a lot of environmental, social aspects which are linked to the quality issues. So in master plan, we should consider all these aspects. The water quality is the prime component in this. And in this project, like 15 River Basin project, we have, as specified in the TOR, we have identified some locations where water quality samples have been taken and they have been examined for those parameters. So we are producing this information there are some predefined locations wherever the gauging sites are there. We are considering the water quality aspects. What is the, I mean, permissible, what is the limit of those existing water quality parameters there? So we are producing those. Then aquatic ecosystem, we discuss, forest, we discuss, EIA, you all are aware what is the EIA, so we should consider this in this river basin master plan. Then wetland ecosystem, these are the collectively should be integrated in the RBMP. Then social and resettlement issues, you are aware, if we are building something, if your canal, then command area, if you are building a dam, then this nearby community, the social aspects are getting disturbed. So we should have provision. I mean, once we plan the any project there in the river basins, then their consequences should be studied. I mean, in the detail, what should be the relocation, what should be the resettlements issues would be there, then how you should, I mean, tackle all those issues in your basin. Then these projects, the livelihood, the community structures, their cultural ties are disturbed, so we should maintain, I mean, we should consider all those aspects in the river basin master plan. And these are varying basin by basins, because in few basins you may not see the settlements and all near the river bank or river floodplain areas, but for most of the basins these are the issues which persistent while, I mean, you are developing any project in the basin. So the river basin projects such as dams, reservoir embankment directly affect human settlements and land ownership. You are aware. Then displacement without proper settlement leads to the loss of livelihood, poverty, because until unless you don't have any plan, then it will, I mean, yield to the poverty, social marginalization, then livelihood aspects. Their livelihood aspects will be, I mean, will going to affect if you do not consider all those aspects. Then the social resettlement issues should be, I mean, considered, and these aspects should not be ignored while setting up or planning any project in the river system. We already discussed. Now there are few things how to estimate those aspects, that severity of those issues in the basin. One of my friends in the first session, he was mentioned that you might have heard the term exposure. Exposure means nothing but the communities, the infrastructure, the agriculture fields, these components which are directly going to affect if the inundation, that other issues, I mean, the river system while we are setting up any project. So exposure is nothing but what is the things, what are the components which are directly going to affect by the project, whether it is population, infrastructure, agriculture, you know, whatever component is affecting, which called exposure. Then one is hazard. Hazard is nothing but in master plan, your hazard, like major hazard is the flood extent, depth of flooding, and landslide prone area, earthquake zones. So these are the hazards. So one is exposure, another one is hazard, third one is vulnerability. Vulnerability means the magnitude on which, I mean, the percentage of amount this your exposure is getting, I mean, affected or damaged with this hazard. For example, there is one area where the houses are there, and you assume the 1 meter or 1.5 meter or 2 meter flooding is there, and this flooding is persist for 2-3 days near these houses. So your, depending upon your water level there, the inundation water level there, the vulnerability would be different. For example, if you have kacha house there, then kacha house, the 1 meter flood, the 100% damage may occur. Okay, for the, if the kacha house is there. So the vulnerability is 100%. Whatever the house construction cost is there, let's say 1 lakh rupees, 2 lakh rupees, the 100% will be considered as a loss. And if you have the pakka building there, the RCC building is there, if there is a 1 meter flood depth is there for 2-3 days, then there will not be, I mean, much loss. So vulnerability is less, I mean, 10%, 5%, 2%, considering what is the asset in the building. So likewise, the vulnerability, how much intensity of the damage is there, that we call the vulnerability. Same time, in the Pakka house, if your inundation duration is more than 2 weeks, 3 weeks, 15 days, or 1 month, then you may have a huge loss, because the construction cost of the Pakka house is bigger than this Kacha house. So, and if that sense, if duration is more than 2 weeks, 3 weeks, then the vulnerability will be higher, 70%, 80%, even the 100% for some places. So, this is how we calculate the flood loss. Three components are there. One is hazard. Hazard is nothing but your flood, earthquake, drought, tsunami, whatever your this hazard which is creating the losses in your river basins. So this is hazard. Then exposure, what are the infrastructure, population, agriculture, what is the area, is agriculture area there in the surrounding area, what are the settlements in terms of area, communities, the urbanizations. So this infrastructure is called exposure. And then you are calculating the risk from the flood, then vulnerability comes in the picture. This depends upon the type of infrastructure as well as the intensity of the hazard, okay, their duration. So this is how it is, because this is required while calculating the, because in the post flood evaluation, this is required, because what community is affected, on what basis and which level of severity they have been affected. So while estimating the flood loss or the hazard loss, then these three components comes in picture: exposure, hazard, and vulnerability. Hope this is clear to you all. Then resettlement issues in the river master plan. You aware all those things, you might have come across these issues in your river basins, in your work. Displacement of the communities, then land acquisition and compensation. These are the procedure I have explained while estimating the losses and all, how to calculate the cost of the building if the owner is residing there in this area. Then livelihood restoration, job, training, income, all those things, social services, infrastructure, access to the, if there is a flood, then these services are getting disturbed, like health services, education services, utilities. You may not have power for few days. So I have seen some places like in Vijayawada. I was having one discussion with the client. We are having one project there. So the Vijayawada city, the Krishna Basin breach was there in 2022. Okay, one of the bank was breached due to the heavy release of water, because in the southern India there are a lot of cascade dams are there. So one of the dams, there was a huge water release. Then there was one embankment breach was there near Krishna, where Vijayawada city is there. The prime locations were there in this near this dam, Vijayawada, this city. So the location, I think few kilometers of the area was inundated for 1 month. So people were there on the roof of this house, no electricity, no good water. The horrible situation was there. So before this event, or before this issues, before the inundation, we should have a clear mechanism. If the inundation in this area is there, what would be the escape route, what should be the livelihood aspect, what should be the rehabilitation programs, all those things we should consider in this master plan. So this is the example of Assam. Some published studies are saying that 2.5 millions are displaced on annual basis by the flood in the entire Assam. The numbers are in the Lakhimpur is the down where the Dikrong river is passing through. So displacement is, number is there 1,73,000. Then Golaghat, one of the most flood prone district in this Assam. Then Guwahati, then Karimganj, then Dhubri, which is downstream part of this Assam. So displacements, you are relocating the community, then these are the numbers in the Assam, and these are the annual numbers which have been estimated by some agencies like NDMA, National Disaster Management Authority, has estimated those numbers. So similar kind of number we should estimate what is the area is going to be affected, and what are the total population which is there in this area, number of houses which are going to affected. This kind of estimate we should have in this. in summary, the social assessment are there, consider project program, then stakeholder consultation, you discuss with the communities, how much exposure is there, content is there, how much population is there, then you should plan and then identify social factors, analyze data, whatever data we have discussed, develop plans, consult with the stakeholder who are living the communities, NGOs, this region, then ensure the capacity building training programs. If the flood is there, how to evacuate the public from there, what would be the routes. So we should plan the capacity building programs as well. So integration of river basin, these social aspect, hydrology, environment, social, then safeguard, then basin planning, reduces the repeated. So this is the things we have already discussed in my presentation. The institutional, there other than department, there are some guidelines, National Water Policy, IWRM 2016, CWC 2007. These are some guidelines which are focusing, recommending we should consider these social and environmental aspect while preparing the master plan. Institutional framework, the agencies which are responsible for these plans, like on central scale, the Ministry of Jal Shakti, Central Water Commission, Brahmaputra Board for your region, then NDMA, National Disaster Management Authority for rehabilitation and then for evacuation point of view, then Ministry of Environmental and Forest and Climate Change, they are responsible for providing clearance for environmental and social issues. So then safeguard, some state ministries, the departments are there, Ministry of Rural Development, Social Impact Assessment, Compensation and Livelihood Aspects, Restoration Programs, then state agencies, state water resources departments which are directly involved, links to those aspects, River Basin Organization, if you have any, like Meghalaya, we have Meghalaya Basin Development Authority. So these are some organizations, state level specific agencies are also there. Revenue and rehabilitation departments. Revenue means department that plays role because how much land is affected of the landowner. So revenue is the department which calculates these kind of aspects so that they can decide the compensation for the communities which are affecting to the flood. And then local communities, Panchayati Raj institutes, the rural NGO bodies, the groups, public consultation, social audits. So all these agencies are there where you should consult or we should consider the data, they should plan what are their policies, guidelines, governance mechanism while there is the flooding or the hazard is there, then what should be the escape route. We have already discussed this. There are some case studies. I have shown you these case studies in one of my presentations. Flood situation in Assam, severe floods. Nowadays, the occurrence of flood is increasing. Almost on every year, we are witnessing those floods in urban areas. Assam and Silchar, the Guwahati and Silchar are those example of those floods. And the number of population is affected. 2022 Assam flood. These are some figures. We have witnessed huge flood in Assam. So this is the brief, not fully I have covered, but brief. What are the environmental and social aspects we should consider while designing and preparing our master plan? And these are varying. These will be varying with basin to basin, considering their aspects, like water quality aspects are there. Some of the basins where you have to focus on the water quality aspects. This is the prime component. Fisheries production and all this, tourism and socio-economic profiles. These are there we should consider in the master plan. So because we have hydraulic modeling sessions, and one more thing I would like to inform you, because yesterday we have already conducted one hands-on session on HMS, hydrological modeling. So we would like to continue because of the limitation of time yesterday's session, we would like to continue this. We will cover this in some time today in the afternoon. We will cover, because this is the important activity. We should know how to estimate the discharge for a particular basin if you have rainfall data in hand. In the departments, people are using the Excel file. See, the rainfall is 100 mm. If you convert this rainfall to the runoff, this is amount, but they are assuming the losses on thumb rule basis. The forest area, agriculture field, they are considering 40%, 35%. For urban area, where lot of paving or paved surface land use is there, then they are considering 80%, 85% because of some assumptions. So this is not the accurate method. To estimate the discharge for a basin, how much discharge is my basin is generating, then you should know this HMS hydrological model. So hydrological model, just to recall, is nothing but to convert the rainfall to runoff, and how much runoff I will get if X amount of rainfall is there in my basin. If you have this runoff is discharge, the flow at the outlet of your basin, then you can use this flow in the hydraulic model. Another model is, we are using here HMS, RAS, Hydrological Engineering Center. RAS means RAS, River Analysis System. So in the HECRAS, you should consider as a input, the flow as input in your HECRAS model. Then there are some routing function within your river channel. HECRAS is used for river channel only. When you need to put some cross section of the river system, you need to define the land use in the river system and the river as well as the floodplain area, left bank and right bank. Then what output it will give? This hydraulic modeling, the inundation map in your area, considering, depending upon the what topographic data, the DM you are using in the hydraulic model, it will give you the inundation map. So you can prepare the good inundation map as a output from the hydraulic model. So I'll quickly take you through this hydraulic modeling, maybe next 15-20 minutes, and then in one go we can have the demonstration of the HMS and HECRAS, both the models. The hydrological model, who have left or who have missed yesterday's session, they can continue, and we can also have this demonstration on hydraulic modeling. So this picture, the middle part is a river stream where there are two banks, left bank and right banks, and near the river you have it or may not have the wetland. When the storage water bodies are there, where sometimes when the high flood is there, they are accommodating the water, then there is flood is recedes, then they're contributing the water to the river system. Like the nearby area to the river is the wetlands. Then development areas there, some zones are there within the river system. Yesterday I shown you the floodplain zoning guidelines map. There are 3 zones are there, 1, 2, 3 zones are there. So development areas are there. So beyond the channel, there are channel and there are 2 banks, left bank and right bank. I will show you the more details in the cross section data. And beyond the bank there are some zones area we call floodplain. Okay, so in the picture also you can see. So application of HECRAS, the hydraulic model, computing the water surface profile. Yesterday we have discussed what is the water level at the downstream site. I have mentioned there are 2 methods, for issuing the forecast, water level forecast at the downstream station. One is gauge to gauge correlation. If you have water level recorded at upstream gauging site, then depending upon the travel time and the slope of the river system, you can estimate the water level of your downstream station. So one is the conventional method, which is gauge to gauge correlation method. Another one is from the HECRAS, you can estimate. HECRAS consider all those river dynamics and the routing functions, and it will provide the water level at all the locations wherever you have considered the cross section data in your model. Floodplain management, while you assessing the social aspects, the floodplain, the communities which are the communities which are going to affect from the flood, then you need to generate the flood map. Okay, then you should overlay this flood map in the GIS. So flood map can be generated from the HECRAS. Then all this hydraulic infrastructure like bridge, culvert, embankment, we can put in the HECRAS, because these infrastructure are part of the river system, and then HECRAS simulates the water in the river system, so we can incorporate those bridges, culverts in the HECRAS. Then levee, as I mentioned, embankment. Dam break, we'll see if time permits. We'll try to consider this aspect, important aspects. We can do the dam break analysis using the HECRAS. We can generate some scenarios. If you have your dam reservoir in your basin, then you can consider the hypothetical discharge, upstream discharge. Hypothetical high magnitude discharge you can consider, and you can hypothetically breach this your structure weir in the HECRA system. Then once you have high magnitude discharge, upstream water level, storage in your reservoir, if you are breaching this weir or structure in the HECRAS, then it will create a scenario in the downstream. How much area will be going to inundate, on what would be the level in the downstream part, that we can consider in the HECRAS. Then channel modification industry like dredging and all we can do. We can those river training works we can do in the HECRAS. We can see without river channelization or river training, this is my inundation, and I have implemented or incorporated the river training in the HECRAS. Okay, then my channel capacity has been increased, and how much the inundation area has been reduced. So these studies we can do in the HECRAS. Then channel modification, sediment deposition, sediment analysis we can also have. Yesterday my fellow presenter was telling that we can do the sediment analysis in the HECRAS. Then water quality aspects, there are provision, but we are not considering here. We are using some other tools. And water quality assessment is the Excels we are doing, because there is no need to use the tools for that purpose. But these are the capabilities HECRAS, a hydraulic model can handle. The data requirement, geometric data is nothing but the cross-section data, surveyed cross-section at your river location, different locations. As I mentioned yesterday, in the cross-section there are 3 benchmarks. One is warning level, danger level, and HFL. So these data, cross-section data, we can put into HECRAS. And the next one, digital elevation model. You are already aware of what is this DA model. Surface, providing you the elevation on the pixel basis. Then manning roughness. This is the important parameter HECRAS considers. Land use. This data comes from land use. What type your land use is there. The manning roughness coefficient. Higher the roughness, lower the velocity, higher the depth. So we need to define this manning roughness. We'll explain you how to define the manning roughness while we will be having demonstrate. So for channel part, roughness, because there is no vegetation in the channel portion, so roughness would be lesser in the channel part. So channel part velocity will be always higher. And the beyond the channel part, beyond the bank area, both the left bank and right bank, some vegetations are there, considering depending upon the the location of the basin, type of the river. We have some vegetation, so the roughness coefficient would be slightly higher for the overbank areas. Okay, so the water velocity would be lower. Then any structures, bridges, culvert, all those hydraulic structures, weirs, if you have any these information in your basin. And study flow data. Flow data is nothing but, as I mentioned, the output of HEC-HMS. When I use HEC-HMS means hydrological model. The output of HEC-HMS is flow, discharge, the flow magnitude, time series data. So this we call hydrograph flow data, and we will use as a input to the HECRAS model. Then there are some boundary condition. I will not discuss here. We'll put some boundary condition also there, upstream and downstream. And this flow data is the model consider this flow data as a boundary condition. Okay, so there are some nodes where we put the flow data there. This is the window of HECRAS. If you open this HECRAS model, the HECRAS looks like this. File, projects, sediment, unsteady flow data, steady flow data. Then RAS mapper is the option where we can visualize the inundation of the HECRAS, generated by the HECRAS. Then some hydraulic properties, because this is being used for the river system. So there are some properties, the river properties. This manning roughness, your expansion coefficient, construction coefficients, what is your flow area is there, the velocity is there. So we can get all those information, the parameters as a output of HECRAS. But the main output is water level or inundation map. We can visualize, see the tabular data, the spatial data we can see in the HECRAS. This is the plan view of HECRAS geometry data. Plan view means if you see from top, these are some red points are there in the map. These are the cross-section locations. There are two rivers. This is an example of Nonba river from the Meghalaya. So there are two river systems which are joining at a point, in the downstream point, and there are some different, red lines are there on the river. These are the cross-section locations on 500 meter, 0, 500, 1000, 1500, 2000. So on the 500 meter interval, there are few cross-sections are there. This is the plan view we can see in the across. If you open one of the cross-section, one of the location, you can see this kind of data would be there, the cross-section data. Okay, so elevation versus their stationing. Stationing means from one point to another bank, from one bank to another bank across the river. What is the elevation profile? Okay, so for few locations, we have to put this elevation profile in the as a cross section. And these are some how to put the boundary condition. The mean to do basin map is there. Okay, not known by the mean to do basin is there. So how to put the boundary condition? I mean boundary condition means the flow data. How to incorporate the flow data here? Then if you have time series data in the DSS format, DSS is not this decision support system. This is the data storage system, the compatible format of the HEC models. So once you have the data in DSS format, then you can directly link this data like this. You can also put the data in manual form. We'll let you know how to put the data in the class. Then this is the data input plot I have given to the model. Flow versus time. Upstream boundary condition I have given. This is the plot. This is the tabular form of the data. And like HEC-HMS, we need to create one computation or a plan where I should, which will be used for a simulation point of view. So simulation window, I need to define start date. Suppose I have 1 month data. I want to simulate the HECRAS model for August 2024, where the heavy rainfall event or heavy flow was witnessed in the river. So for that purpose, I should have at least 1 month data for this. In 1 month data means the HECRAS in inflow boundary condition. So if I have 1 month duration, 30 days data, then I can simulate the model within this period. I want to simulate for 5 days only, then I should consider from 10th August to 15 August 24. I can select 15 to 20, 25 to 30. Within this period, wherever I have the data, I can simulate the model for entire full month. But once you incorporated the data, then for simulation point of view, we should consider within this time frame, wherever your data is there. If you consider your simulation time beyond this data period, then it will throw a error. I mean, it will ask you to recheck your data because your simulation window is beyond your data, period. So you should consider. Then there are some intervals on what frequency you would like to take your output, whether you want to on seconds, hours, day, which basis you would like to take. So there are some intervals are there. This is the window. Once you integrated, all the data has been considered in the model, cross-section data, survey data, all this data has been considered, then you can simulate your model. This is the simulation window. The blue line is showing, okay, your model is successful. In the the bottom of this message log, you can see your model successful. Finish the unsteady flow simulation, means you have completed your simulation. If you have any error in the data, input data, then you will get an error here in the red bar. So you can go back and it will also show you HECRAS, HEC-HMS as well as HECRAS. The good part is that whenever there is a model simulation error, it will tell you what is the main error. It will tell you go back and correct this error and resimulate it. So this is after the simulation. In the first, the previous slide, I have shown you the cross-section data without any inundation, without any water. Once your model is simulated, you have performed the simulation, you will see this kind of window. This is the profile of one cross-section. Only a single cross-section profile is there. Your water level in the cross-section, how much is from 2272 to 1230. 3 meter water level is there in your cross-section. Likewise, you get the detail for at each cross-section. And this plot is longitudinal profile. The black dots are your cross-section from downstream to upstream. and this is the your water surface profile. If you plot the longitudinal profile of the river system, and these are some time series data, you can see the data in the tabular form, and the hydraulic property as particular cross section, you can see all this velocity, head, the critical slope, velocity at channel, depth of the channel, conveyance loss, flow area, reach length, all these information you can see as a detailed output table. And this is finally your inundation map. This is the river system, and what this color code is showing, the depth of the water. Dark blue, higher depth, because in the channel, main river channel, you will always get the higher water depth. Okay, so that's why it is in the dark blue, and I mean over the bank area will get light this blue or light green color. The depth is varying from 0.5 meter, 0.25 meter, like this. And the river channel depth is varying, I mean 1 meter, 2 meter. And this map you can import in the GIS. And again, once you imported this map in the GIS, you can decide the color combination. You can change color dark blue to red blue or whatever color combination you would like to have in your map. So you can prepare a map in the GIS. So flood inundation map you can prepare the output of hydraulic model. This is the brief about the hydraulic model. We will cover it more while we will be having the hands-on session. Thank you for your time. We can have a tea break and then we'll resume for next session. We'll be having the hands-on. Thank you.